So, I'm Dion.
And I'm Quinlan.
And we have a video to start our presentation first before, show some clips from some Pixar movies.
Please don't go away. Please. No one's ever stuck with me for so long before. And if you leave, I remember things better with you. I do. It's there. I know it is because when I look at you, I can feel it. And I look at you and I'm home.
Don't worry, Woody. In just a few hours, you'll be sitting around a campfire with Andy making delicious hot schmoes.
They're called s'mores, Buzz.
Right, of course.
You won't tell me what to do, what not to do, trying to make me be like you. Well, I'm not going to be like you.
So everything that you just saw was created with mathematics involved. So our topic is obviously math and computer animation. And the reason why we chose this was because we've seen most all of these movies and we remember watching them when we were kids. And I mean, how many of you have seen at least one of these?
I guarantee all of you
Yeah.
have seen at least one of these movies.
So,
And I think another reason that we chose this is we wanted a really unique topic. I think because, I mean, there's lots of topics where you find just the velocity and the speed and the stuff like that. And we wanted something different because our presentation, it doesn't involve the most complex math, but I think it's the ideas behind it and it's finding something that you think is really interesting is why we chose this.
So going into the history a little bit, computer animation started in the 50s, mainly because of the Cold War, and the first university to really use it was MIT, and they used it to track missile trajectories and things like that, and run simulations with weapons. And then beginning in the early 1970s, movies started using CG graphics. None of them were completely animated.
These were just little short little clips of something like a rocket taking off or somebody shooting a gun, just little tiny 5-second things, nothing close to what we have today.
The first movie to really push a lot of CG was Tron, and that used a full 20 minutes of CG animation. So going on, they kind of developed wireframe imagery later on then, which is a very early version of computer animation, and it's mainly made up of just lines and squares and other geometric objects to create computer graphics.
And then motion capture is a process that captures images from real life objects. And motion capture is different from computer animation, because with computer animation, this is all created on a keyboard computer, and with motion capture, they actually put sensors on you, like for the movie Rise of the Planet of the Apes.
Yep, they
I
got the
think that just came up.
gorillas.
All the gorillas were all using motion capture, and it looked very lifelike. So
And
there's
then-
a difference there.
Star Wars Episode 1 was the first movie to use a fully CG character.
Jar Jar Binks, and then all the droids.
So Toy Story was kind of the first hit animated movie, and it was the first movie to use all 3D animation. And it took 28 animators, and it had over 1,700 individually rendered shots. And they had to like do all of those one by one going on to get through the movie.
And when we were reading about Toy Story 2, I think most of the animators and most of the people working at Pixar didn't actually think that it was going to be very much of a success at their start. They just were kind of doing it.
Yeah.
And then they were honestly, they knew it was going to be good, but they didn't know how good it would be and how much of an impact it would have on animated movies. John Lasseter, who is one of the head people at Pixar, he's done a lot of movies, you've probably heard his name before. He was nominated for a Special Leadership Oscar for this movie in animation, and then also they created a special award Oscar just for the science and engineering behind how they did all these new graphics and animations.
So nowadays, we see computer animation all the time, whether it be in special effects or fully 3D animated movies.
You just turn on the TV and you're going to see it. Absolutely.
So Pixar has released 14 feature-length animation films to date. Out of all of those, Toy Story 3 made the most money, and it made around over
$1 billion, which is incredible for an animated movie.
And Pixar now has 850 employees at its headquarters. And then their newest film, which is Inside Out, is set to release pretty soon.
Yep. And then another thing they actually use most of their animation for is their short films, which you'll see sometimes in the trailers and in the special edition packs of the DVDs.
Yeah.
So, basically, for them to create these characters and almost create anything using 3D animation, they use subdivision of planes, which I'll explain a little bit more later. And subdivision of planes is a process in which hard edges are smoothed out to create an organic shape from a geometric shape. Because you can't just tell a computer just to make a shape, just make it smooth. You have to create a hard geometric shape, and then it smooths out using subdivision, which
And
we'll
turns
get
it
to
into a curve.
It turns it into a curve, which we'll get to in a second. So for the history of subdivision, subdivision algorithms first appeared in 1974, and that's kind of when you can see the Westworld, that first animation use of CG. That's when that started to appear, so obviously those would appear at the same time. And also, since their appearance, they have been used to solve problems in engineering and obviously computer animation.
So you would usually think of computer animation as more of like an artistic discipline, like drawing out characters and stuff, but it's much more math than that. In fact, most of the people who work at Pixar do have math degrees
Yes.
to do this kind of stuff.
Because you need to be obviously artistic to create these things and to draw these things, but to understand the math behind them, it's nothing easy. Like when we were researching this, we found an article from Caltech, and that's like
It
an
seemed like it was in a
insane-
foreign language.
I didn't know what I was reading. I honestly didn't. So subdivision basically consists of adding midpoints to line segments and slowly curving them until they are smooth. As you can see here, we have the diamond shape, which is a geometric shape. Points are added and then it's curved out to create a circle, and we have an example of that.
And the more points that you add, the more it gets curved. So
Yep.
if you want to make a perfectly curved shape, you need to add an infinite amount of points.
And there are different programs that the animators use to create different shapes, because obviously, I mean, not everything can just start out from a square. So, and kind of like we said, infinite points are added to the shape to make it completely curved around.
So that's an example of what a square might look like
Yep.
after subdivision is used on it.
If you look at before they animate these movies, you know, they have those like kind of blocky shaped things.
I'll go back to it.
Yep, go back to that.
Like, you can see it's just a bunch of squares and his face looks really blocky,
Mhm.
and as they go on, they smooth it out.
And it eventually turns into a what you see in the movie. So here's all characters are originally blocky and not smooth. Subdivision is used to make them to look like what we see there, a cube turning into a sphere. So let's say we wanted to create a balloon from up. I would start out with a diamond, which I created here on this plane. So as you can say, each length is 5 units long and it is perfectly a square. So what we would do first to create the subdivision is we would subdivide between each of the segments in the middle, and we would place a point there. So to find that, we would use the midpoint theorem here, which is just basically simple math. This is something you guys could have done. We could have done in 7th grade. So 2.5, 2.5, 2.5, negative 2.5. Obviously, you can see these 4 points are created and placed there. And then basically you do it again here, and then 3.15, 1.25, 1.25, 2.75. You get the idea. And then I would connect these new points that are created here. So you can see the segments connecting between them. And then once again, we take off all the other points, and then you can see we're starting to create more of a organic shape than the purely geometrical one we had before. So then I stopped doing the math for the midpoint after this, but and then we put the purple dots in there for the midpoints between each of those. So, and then you average it out. This is the same amount, they were just all averaged out for the distance between each other. And then you would obviously add another subdivision between each one. There's a lot, you're gonna have to just get it quick. So then as you can see, our form has turned from that initial diamond that we had into a circle now that the animators, I can't talk, would be able to use to make a balloon. So then also, another thing that we actually noticed when we were doing this, that the limit between the space of each point, because you know we initially started here and here with points, just those 4, the space between each of the points is slowly decreasing as you add more points. So
Until it gets to 0.
Until it gets to 0, well, yeah, basically.
Yeah.
So the limit between the spaces is approaching 0. And then also, another calculus that we actually noticed between this would be that eventually, as the circle is created within that diamond, that the point right here, the midpoint, that'd be negative 2.5, 2.5, is tangent to the line right here, which is interesting, I thought. So that's the line there. So for the slope of the line.
So there is a way to find where the point will end up and where your B infinity will be. So we can call this polygon Mike Wazowski from Monsters Inc. And we're gonna try to
Doesn't
make
really
it.
look like him.
So what you do to get these equations is you use the midpoint formula to find a sub 1, which is right there.
Which is
and
the
there's-
subdivision,
yep.
which kind of we were talking about before a little bit.
And then for C sub 1. And to get the equation for B sub 1, you have to use this technique called eigenanalysis, which, I mean, if we try to put that in here, this would be like 100 slides long, but basically what it is it uses matrices to find an equation.
It's beyond me. I have no idea.
And what we can find is, when we substitute these in, and we put it over 6, we can put all of the other midpoint equations in, And we can see that a sub 0 plus 4b sub 0 plus c sub 0 over 6 is equal to the same as a sub 1 plus 4b sub 1 plus c sub 1 over 6. And as it goes on, we keep substituting them in, and you can see that a sub 2 plus 4b sub 2 plus c sub 2 is also equal to the original equation. And we keep going on
And you keep substituting.
until we get to a sub infinity plus 4b sub infinity plus c sub infinity. Now, eventually the limit between points gets to be 0, so you can change these to b sub infinity, since these will be right next to each other. So instead of a sub infinity plus 4b sub infinity plus c sub infinity, they're all changed to b sub infinity over 6. And when you add those together,
It equals 6
b sub infinity
over 6.
which means that our original equation
The one that we started out with.
of a sub 0 plus 4b sub 0 plus c sub 0 equals b infinity.
So in subdivision and other fields, subdivision of planes is used in other studies such as linear algebra, which is an extremely advanced math class. So that's why I understand this. But linear algebra is the study of lines, planes, and subspaces, and I think there's vectors in there too. And midpoints can be used to find elasticities of certain graphs in economics, which I know we learned about. I don't remember it, but we learned about it.
So you can also create 3D shapes. And to do this, the animators could take a graph and flip it over the x-axis to make something like a simple ring or another 3D shape, and they could use that to combine
Yeah.
and make a new 3D character or
Mhm.
object.
Which is what we were doing in class with integration. So we're going to the integral now. So the idea of the integral was first thought of by Eudikx, who came up with the method of exhaustion, which was used to find areas and volumes by breaking them into an infinite number of areas and volumes.
And he was Greek,
He was great.
hence the
So the formal process of integration was eventually created by Cavalieri,
he was Italian.
and then the idea of the integrals was integrated into calculus with Leibniz and Newton.
And that was a big part of the fundamental theorem of calculus, that you can take the derivative of an integral
Mm-hmm.
and also the integral of a derivative.
Yep. The basis that those two are complete opposites, even though they didn't completely understand what those were.
So let's try to make a balloon from up using this process.
Sorry for a really janky graph. It doesn't look good.
So we found the equation of this curve,
Just a parabola there.
which was negative x minus 1 squared plus 1. And we had to find the area under this starting out. So we took the integral of that from x equals 0 to x equals 2, since that's where it went at the x-axis.
Yep.
And so plugging that in, we got 2
2.
for the area. Which looks a lot nicer than that. So now to find the volume, we can take the same formula of the integral that we just used, multiply it by pi, and then square f of x in there to get the volume and rotate the object around the x-axis to make it 3D. So there's our new equation. And using that, we have a balloon that we flipped around, and the volume of that balloon is 4 pi.
And then finally, we have integration in other fields, and integrals can be used to create nearly any 3D shape through the disk method and the washer method. And integration can also be used to find the average value and overall value for an equation between 2 points.
And then also the area
Yep,
and volume, as just showed. And that's it.
and that's computer animation.